Hello, welcome everyone. In this video, I'm going to work out another property of derivatives called the product rule of derivatives. So we apply this particular rule when we have a product of two functions. When they're multiplying, we want to take the derivative of this expression. That's when this gets applied to. So let's take a look at what it looks like. So we have these two functions multiplying. We have a function f and a function g, and they're multiplying together, or the expression is the product of these two functions, and we want to take the derivative of this product. So how we do that? We take the derivative of the first term, or the first function, times the second function plus the first function times the derivative of second function. So let me just rewrite it again. If we want to take the derivative d over dx of f times g, which is a product of, this expression is a product of two functions, and we want to take the derivative of this. So it's going to be the derivative of the first term in this expression times second term plus first term, or the first function in the expression, times the derivative of the second term. Okay, so this is how we will solve for the derivative of a product of two functions. So let's go ahead and apply this rule to one of our examples and work it out. So here's our expression. We want to apply this rule to this expression to solve for the derivative of this expression. So let me write it down. We want to take the derivative of x squared minus 4 times 2x plus 2. Okay, so now this is our f and this is our function g. So they're multiplying together, and we want to take the derivative of these this expression where the two functions are multiplying together, and we're going to apply this particular rule right here. So let's take the derivative of the first term. So we have, let me just write it again. So it's going to be d over dx of x squared minus 4 times 2x plus 2 plus x squared minus 4 times d over dx of 2x plus 2. Okay, so we just plugged in these functions are the terms into this expression right here, and this is what we get. So now when we take the derivative of this right here, the derivative of 2x squared minus 4 is just basically just derivative of this, because the derivative of constant is 0. So and the derivative of 2x to the 2 would be just 2 times x to the 1, 2 minus 1, right? And then that would be just x to the 1, and the derivative of constant is just going to be 0. 4 is 0. So, and then we have just 2x plus 2 and plus x squared minus 4 times let's take the derivative of 2x would be just 2 times 1 times x to the 1 minus 1, because x has a 1 exponent. So I'm just applying the power rule here, plus the derivative of a constant is going to be 0. So here we have just 2x, and that multiplies with 2x plus 2, plus here we have x squared minus 4, and when we simplify this we just get 2 times 1 is 1, x to the 1 minus 1 is x to the 0, which is just 1. Anything raised to a 0 exponent is going to be 1, except 0, of course. So this is going to be just 2. All right, now we can rewrite it again if we want to, or we can just simplify it further if we want to. This 2x multiplies with 2x becomes 4x squared, and then 2x multiplies with 2, that becomes 4x, plus this 2x this 2 multiplies with x squared term becomes 2x squared minus 2 times 4 is 8, and now we can combine the like terms here. So you have 4 and a 2, so that's 6x squared plus 4x minus 8. You can simplify it or you can leave it like this. The important thing here is to know how to take the derivative of a product of two functions. All right, let's go do one more example. So here we have 3x to the second minus 4 times square root of 3x minus 4. So we are going to apply the same rule here. It's going to be the derivative of the first term, f prime, 3x squared minus 4 times just the second term. We just write it as a multiplication. And now we have our first term right here, 3x squared minus 4. And then we take the derivative of our second term, which is 3x minus 4, square root of 3x minus 4. Now let's go ahead and take the derivatives here. So the derivative of 3x squared is going to be just 3 times 2x to the 2 minus 1. And the derivative of constant is just 0. And then we have this multiplying with the square root of 3x minus 4. Plus, we have 3x squared minus 4. Now the derivative of this inside is going to be a little bit tricky because we have a square root. So square root itself has an exponent of 1/2. So I'm going to write it as, let me just write it to this 3x to the minus 4 to the 1/2. So this basically what this root means, square root means. So now if we take the derivative of something like this, we use the power rule. So we bring this 1/2 to the front times 3x minus 4 and 1/2 minus 1. We subtract 1 from the exponent. Now the tricky part is now we have to take the derivative of this inside. So when we take the derivative of inside, the derivative of 3x is just 3 minus the derivative of 4 is just 0. Okay, so that's a little trickier than just this simple right here when we did take the derivative of 3x squared minus 4. So when we go ahead and simplify this, this becomes 6x to the 1. 2 minus 1 is just 1, right? And then this multiplies with square root of 3x minus 4. Plus we have this. This is just 3x squared minus 4. And then we have 1/2 here multiplying 3x minus 4 times 3. And 3x minus 4 to the 1/2 minus 1 is negative 1/2. So, all right. So this is really the final answer. You can simplify it a little further if you want to. So I'm just going to make this 6x. And that multiplies with 3x minus 4 plus, we can bring this 3 times 1/2, 3/2 to the front. So we have 3x squared minus 4. And then we have this term right here, 3x minus 4 to the negative 1/2. Okay, so this is our final answer for this example. All right, if you like my video, please like it and subscribe, and you'll be getting a lot more videos similar to that coming in the future. Thank you.